Or you got it? You okay? What's that?
Work on it together.
Work on it together. Okay.
You're not one, you're not mine.
Okay. So work on this together, just because you know, this is going to be really easy for you guys in the future. But we'll just introduce it here and make sure nobody's left behind. Right? Isn't that what Jesus said? Ohana means family or something. Okay, so looks like we have how many irons on the left to start with? Wait, yeah. Okay. One, and on the right? One. Nitrogen? Two here? Here? Three? Oxygen? Six or nine? Nine? Here? 11. Here? Hydrogen? 5. 4. Okay. So, you know, you can look around and see stuff that, hey, that looks easy. I just see real quick here. There's two nitrogens. Nitrogen's only here. Oxygen's in both, right? Hydrogen's in both. That's kind of messy. Irons are the same, so you're okay. But it looks like if we change this to a 3 really quick, that'll adjust this to a 3. Is that fair to say? How does that change my oxygens now? 12? And hydrogens? 6? Got a little more there. Okay. Oh look, I need 1 more oxygen and 2 more hydrogens. Too bad I don't have a molecule that has 1 oxygen and 2 hydrogens. Oh wait, I do! Does that do it for me? Is that right or no? Okay. So, nothing special here. We make the list so we can visualize it, but in the future you'll see that you don't need the list. And we're just kind of going back and forth, guess and check. Okay? Nothing terribly special. There's a couple of tricks, one of which we'll show you right here on this next slide. Any questions about that? Okay, how about this one? Why don't you try this one? Consult with your neighbor so that they can learn too. Oh, I forgot to tell you what you're supposed to do when I give you one of these. When I give you a problem like this and say, okay, work with your neighbors, here's what you're supposed to do. First of all, you know that you know what's going on, but that your neighbor is kind of, not really. So what you do, to be nice and kind, you say, you pretend like you don't know what's going on. You say, I don't quite get what's going on here. Can you help me with this? And what that does is it makes them feel like, oh, thank goodness. I thought I was the only one who knows what's going on. But if you do know what's going on, you should reply to be, again, kind in return. Well, I'm not sure either, but let's work on it together and see what we can do. Okay? So that's how the conversation is supposed to go, just in case you're confused about how it's supposed to go. Then both of you pretend like you don't know what's going on and help each other gradually along with it. Okay? Just thought I would interject that and make sure that that was clear. You guys probably already knew that.
So why was it Colorado, right?
Yeah.
They made the announcement, this was about a month ago. They found out that 90% of rainwater in Colorado, 90% is made up of plastic.
What's that mean?
So the plastic that's in the ocean is somehow evaporating. And it's coming back down in the rainwater. And it didn't make sense to me. But that's what they're reporting. So I just wondered, I was going to mention it, but I thought, yeah,
have to look into
Does not make sense.
No, because plastic.
Well, they're saying yeah, plastic solid. I mean, I don't, and, the way they're reporting it
Yeah.
is, like blah, blah, it's
Maybe
just
they say
straightforward,
something.
but I think there's
Yeah.
all these other subtle facts that
Well,
they're not, they're not really being specific.
we'll look it up. We'll look it up and try to find out what it is that they're trying to convey, right?
It's weird, huh?
I mean, maybe small amounts of plastic can evaporate, just like the edges, just like the single molecule.
Yeah, now, they weren't. Actually, I think the evaporation part wasn't reported. I think that was came from a conversation I had with my nephew, who's only 13. I think they just made a straightforward
Yeah.
that 90% of the rainwater in Colorado just made of plastic.
I don't know what that means.
Yeah, I don't know.
Don't forget, let's look it up.
Okay, so getting back to this other problem,
Yeah.
the one before. So I was assuming then that that's correct.
What's great?
So the one before you had,
Because it had two.
it was correct, yeah, with twos, but you're saying no, it's not.
It wasn't balanced. Yeah.
It wasn't balanced.
Different number of nitrogens and oxygen.
We're just going back to the proportions, right?
Yeah.
All right, are we having any luck? Okay, good. C8, H18 plus O2, producing carbon dioxide and water. What is this process? We've already saw this today. What is this? Combustion of octane, right? Okay? Okay, good. So, maybe some of you said, okay, it looks like we need 8 carbons over here, and it looks like we need 9 waters, and that fixes everything except the oxygen, right? Here, currently we have what?
Oh, wait.
25?
25.
25 oxygen on the right, and here we only have 2. Okay? But the problem is because these come in twos, is everybody up to speed right here? Does this make sense? Anybody want to have a discussion about how I got this far? No one wants to talk about how I got to this point? Okay, so the problem is, because they only come in twos, then you'd see, wait a second, it doesn't matter, I'm never going to get an odd number of oxygen. So that means the reaction can't occur. No. That means that, well, what number would have to go there to make it work? All right, 12.5. Okay? And that's good, because what that does is it gives us a balanced equation. So now we do have a balanced equation, but we don't want to deal with fractions here. So we can multiply everything by 2. Good. So multiply this, what's here? What's numbers here? What's 1, and that one multiplied by 2, right. And then this one will be 25, this one, and 18. So that's our balanced equation, right? 2 of these, 25 of these, 16 of these, 18 of these. Should we be able to reduce these numbers down now? No, right? That's why we had to multiply by 2, because we can't reduce them down. Okay, so utilize that 12 and a half or 6 and a half or whatever it ends up being. That's kind of a weigh station, because that's will get confusing if you try to do it without it. It simplifies things a lot. Okay, ready to do another one? Okay, here it is. I'll let you guys struggle on this one for, how long do you want to struggle? 10 minutes? 90 seconds? 120 seconds? And then I'll show you something that'll make it really easy. It's too quiet. Okay, how is it? Anybody finished? Or are you going to finish this one? Let me show you something, okay? If you have a chemical reaction and you can identify clusters of the same group. So here we see an NH4, here we see an NH4, here we see a PO4 and a PO4, the barium's all by itself, C2H3O2, C2H3O2. Right? Then you can just balance those units, right? So I have how many NH3s do I have? Sorry, how many NH4s do I have? 3. I have 3 NH4s. So I know what number is going to have to go here to get started? 3. And then that's going to give us 3 of these NH4 and 3 of these C2H3O2s. How many C2H3O2s do I have? 2, so I'm going to have to make some changes there, right? So you use those clusters, and it's essentially only 4 things to balance instead of all those different atoms. Right? Did you finish? Does everybody understand? Does that seem easier now? Because there's only 4 things to balance? Or is it still kind of confusing? Does that make sense with the clusters like that? Okay. You guys getting it then? Looks like we got 3 here, right? So there's your 3 ways to start. Right? Now there's PO4s, PO2. Here we have 1, number 2 there. So what's this one? PO4s. Varies are still the same. 6. The one with 3. How many? 3 of those groups? Oh, there's 6, sorry. So we need 6 of this and 6 of this. So there's 6. I don't know. Double check. We kind of went fast there. Did you guys get the email about the text announcement about the 2 books in Give and Take? No? So, came out here for you. But there were 2 books in Give and Take that were our kind of books. And they're, you can go get them. But, so here it happens. Did you guys get it? That one yourself? That one? Or not yet?
I have a question.
Mhm.
If you're like working on this, you have heard of this.
That's right.
Yeah.
Yeah, you can't break up the clusters, so the chemicals that are projected there need to stay in those packets, but you can use the clusters to balance, right? Okay. Anybody need more time? Raise your hand if you want more time. You gotta tell me if you want more time. Nobody wants more time? Okay, so here it is. I can see the clusters. Looks like I have some NH4 here, some PO4, barium, C2H3O2, barium, PO4, NH4. Okay, so 3 of these, 1, 1, 2. Did I do that right? 3 of these, 2, 4, or no, sorry, 2, 1, 1. True? Okay, so what? Looks like if I multiply this by 3, and I put a 3 up here, it'll give me 3 of these. But then I need to get more of these. So look at that, 3 and 2. That's going to be a mess. And oh, barium, I need 3. So it looks like this is telling me you need to put a 3 here. And that's going to make that 6. So what do I need here? It looks like this is going to be a what? Was it 3? Look what it looks like I need to do there. A 6, because I have 6 of these acetates here. Sorry, C2H3O2s. So there's a 6 there, now a 6 here. How am I going to get, what am I going to need to put here now? A 2. That goes to 6 and 2. Did I get it? I think we're there. 6 on this side, 6 over there for the NH4s, PO4s, 2 and 2, VA, bariums, 3s, C2H3O2, 6s. So, 2, 3, 1, 6. All right, any question on that? We identified our clusters and just kind of went back and forth. Is that okay or no? Should we practice another one? I don't know why this starts with some. Just start with none. Wait, is that the exact same thing? Oh, that's the balanced equation. Okay. Oops. So we're out of there? Here, I'll make another one. Ready? Okay, there's another one. Let's practice.
Is the first check supposed to be for the PO force to be missing? It's 4-2.
Oh,
That's my difference.
Okay, as soon as you're done with this one, you can come up and show me the answers, and then on your way home. Or the answer. If you feel like, yeah, I don't want to do it right now, then leave. Oops. A little bit of an itty-bitty problem here. There we go. Fixed it. That's supposed to be 2 on that CL, not a 3. How's it coming? Okay, good. Okay, so did you see how I use that change too? Did everybody catch that change I made? So here, that's not 1, that's 2, right? Start with 3 and 6, right? Right, and then start with 1.
Right.
You got it? Great. What's that? So, over here, we put 2. Did you put 2 in front of it? You gotta put 2 in front of it. Can't put 2 in front of it. This is Let's see, does this work? How many do we start with here? 3. How many here? 2. 1. 1. 1. 2. 3. 1. Did you get it? No. Did I hear somebody say they got it? Oh, you think you got it? What values was it?
A 6 before the NH4 and then a 2 before the NH4 and the opposite, and then a 3 before the CL.
Here?
Yeah.
Okay. Let's see what that does. So that's what we started with. Now I have 3 times as many, 3 and 6, twice as many, 6 and 2, and over here 6 and 6, and this is still 3 and 2. Okay, good. We can do one more before class next time. Is that bothering you?